Can quantum magnetometry be done without cryogenics? Imagine measuring magnetic fields with incredible precision without needing to cool everything down to super low temperatures. That's what modern quantum magnetometry is making possible today. Traditionally, many high-sensitivity quantum magnetometers relied on superconducting devices that needed cryogenic cooling to work properly. These devices, like superconducting quantum interference devices, had to be kept extremely cold to function. But recent advances have changed the game. Now, scientists have developed quantum sensors that operate at room temperature, making the technology more practical and accessible. One of the most promising options involves nitrogen vacancy centers in diamonds. These are tiny defects in the diamond's crystal structure where a nitrogen atom sits next to a missing carbon atom. These defects have special spin states that are sensitive to magnetic fields. The best part is, they can be read out optically at room temperature. This means you can build small, portable magnetometers that don't need cooling systems. They can be integrated into chips and used in many fields, from medical imaging to navigation. Another type of room temperature quantum magnetometer uses atomic vapor cells filled with gases like rubidium or helium. These optically pumped magnetometers can detect magnetic fields with sensitivity comparable to traditional cryogenic devices. They work by shining light into the vapor, which interacts with the atomic spins. Changes in the magnetic field alter the atomic states, which can then be measured. These devices are already used in practical applications like non-destructive testing, geophysical surveys, and even in medical diagnostics. Some newer approaches involve using quantum walks of particles with spin states, which could someday measure magnetic fields precisely without needing cold environments. These methods are still being researched but show promise for future room temperature quantum sensors. In short, yes, quantum magnetometry can be done without cryogenics. Technologies like nitrogen vacancy centers in diamonds and optically pumped atomic vapor cells have opened the door to sensitive, reliable magnetic field measurements at room temperature. This makes quantum sensing more versatile and easier to use in everyday applications, from healthcare to environmental monitoring.